This video is going to present some information about logarithms. Logarithms are introduced for us in section 5.1 for this pre-calc class. So we'll start with just, first of all, what is a logarithm? And we will use something called a common logarithm. And what that is a base of 10. So it's based off of exponents of 10. And if you look at what a logarithm pretty much is it's basically this exponent on 10, because it's a log of base 10, that gives you the thing that you're taking the log of. So the log of x equals y could translate into 10, because again it's a base 10, but it's not really written, it's just an understood base of 10. 10 to what power, that's your answer, would give you x, and x is the number that we're taking the log of for this problem. Okay, so that's, be able to translate or transition from logarithmic form into this exponential form will help solve these logarithms. It will help when we solve for the exponents in exponential functions soon. But to begin with, look at just some really base power of 10 logarithms so you can sort of grasp what a logarithm is doing. So for this first example, here underneath these, you're taking the log of 100. You can, of course, take a calculator, type in log and the number 100. There is an actual log button on the calculator. But to actually understand what it's doing, again, these are just common logarithms, the common logarithm with a base of 10. You're pretty much asking yourself or finding 10 to what power would give me 100. Again, the 10 is because it's a base of 10, and the 100 is what we took the log of. So my answer will be whatever power of 10 would give me that 100 that I'm taking the log of. And if you remember 10 squared, 10 times 10, that'll give you 100. So to answer this, the log of 100 is actually 2, because 2 is the power or the exponent on 10 to give the value of 100. Okay. Next example, log of 1,000. Same concept. It's a common logarithm with a base of 10, and you're trying to find 10 to what power would give you the 1,000 that you're taking a log of. So if you take the log of 1,000, you'll get the number 3, because again, 3 is the power on 10 that will give you the value of 1,000. Log of 100,000, next example, same idea. 10 to what power would give us 100,000. You can count the zeros if you like. 10 to the 5th power would give you a 1 with 5 zeros. So the answer for log of 100,000 is going to be 5, because again, 5 is the power on 10 that would give you the number of 100,000. It applies to even decimals, which are still powers of 10. They're just like 1 over 10, 1 over 100, 1 over 1,000. So like the number 1/10, 0.1 is really 1/10, and that's like 10 to the negative 1. So if you're looking for a power of 10 that would give you a 10th, the value is negative 1. The same thing for this 5th example. That's 1,000th. So that's like 1/1000th, which would be 1 over 10 with the 3rd power, which is 10 with a negative 3 power. So if you're looking for, it's almost like you're thinking about how to rewrite the 0.001 as 10 to the negative 3. What power of 10 would give you 1,000th? And that power is negative 3. So if you do the log of 1,000th, you'll get the number negative 3. But again, that's because 10 to the negative 3 would give you the 0.001, the 1,000th that you need. Okay. They're not really special. I put special and popular, but they're really commonly used, and they're very easy to quickly answer. If you take the log of 10, because a common logarithm is a base 10, you're essentially saying, okay, 10 to what power would give me back 10? All right, and any number raised to the power of 1 would give you back that number. So the log of 10 is 1. If the number that you're taking the log of matches the base, in other words, common log of 10, you just get back the number 1. If you take the log of 1, you're again asking yourself, okay, 10 to what power would give me the value of 1? And the exponent that gives a value of 1 is going to be 0. 10 to the 0 power equals 1. So your log of 1 will always produce the number 0. And those are just, again, some two logarithms that appear a lot and are useful when you're solving and simplifying later down the line. So we have a common logarithm, has a base of 10. It applies powers of 10 to give values you're taking the log of. If we look at a natural logarithm, it's a very similar idea, but now instead of the word log, where the understood base is 10, we're now going to change that to a base of the number e, which is the number e that we used in the chapter before, the Euler constant, the 2.7, and so on, irrational number. And it's called a natural logarithm because e is called a natural base. So instead of the word log for logarithm, we're going to switch and use an ln for natural log. But it's still the same idea. If you take the natural log of a number equaling y, you're pretty much finding the exponent on e that would give you the number that you're taking the natural log of. So again, natural log of x equals y, where you have an understood base of e so this is in log form, the formula on the left, and then the formula on the right is in exponential or exponent form. So it would be like the base of e to y, which is our answer, equals x, which is the number that we were taking the natural log of. Okay, so that's sort of the setup on how to figure out how to find the answers if you use natural log. Natural log is not, common log had a base of 10, so it wasn't too hard to come up with powers of 10. But natural log is a base of e, and powers of e are just not something that we know right off the top of our head. So to express or find the natural log of 3, for this first example, we're trying to find an answer. And basically, because this natural log has a base of e, we're trying to find e to what power would give me that 3. And again, you're not expected to know powers of e, but if you take the natural log of 3 and get a value, like calculator, there is an actual ln button on the Texas Instruments calculator. It's right below the log button on the left-hand column. But you definitely need to distinguish between using a natural log button versus the logarithm button when you do calculations. So if I just type in ln and then do 3, the calculator will produce this decimal of 1.0986. I mean, the decimal keeps going on. There's no pattern to it. It never ends, but it's around 1.099. So if I were to answer the natural log of 3 equals what? The answer would be 1.09, I'll say 9 for rounding purposes. And what that 1.099 is if I take e and raise it to the 1.09, I mean, you'd have to keep all the decimals, but it would give you that 3 that you were looking for. So again, if you took your calculator and raised e to that entire power without rounding, if you round, it's going to get really close to 3. But if you raise e to that entire power, you'll get the number 3 back. So the natural log of 3 is 1.099. Next example, natural log of 8.4. Again, you're finding the power of e that would give you the 8.4. So e to what power would be 8.4. So if you take the natural log of 8.4, again, natural log because we're using e, you get 2.12, I'll say 128. It's like 128231706. So if I raise e to that power, the 2.128, I would get the value of 8.4. Natural log of 300, same idea. You're trying to find e to what power would give me 300. So if you just take the natural log of 300, like type in, ln 300 equals, you get 5.70, we'll go 38. Again, it's 703782475, but We're rounding. You'll be asked to round for homework answers, quiz answers, etc. But the power on e that would give 300 is around 5.7. So again, it's kind of the same concept as this natural or the common logarithm before, but the natural logarithm does use a base of e. You are finding powers of e that give the number you're taking the natural log of. The same two special ones exist for the natural log as they did for the common log. If you take the natural log of e, a natural log has a base of e, and if you take the natural log of that, they sort of, I don't want to say cancel each other out, but it's like e to what power would give you e back, and that power is just going to be 1. So the natural log of e ends up being the answer of 1. If you do the natural log of 1, you're like, okay, e to what power is going to give me the value of 1? And just like we discussed before, the exponent of 0 would produce a result of 1. So if you take the natural log of 1, you just get the number 0. And those are helpful whenever we do simplifying and solving later down the line. Okay, so common log, natural log. We'll look at a few examples where you just rewrite, again, so you can understand. These examples are all in logarithm form, and we're going to rewrite them using exponents. If it has log, it's a base of 10. If it's natural log, it's a base of e. So just keep that in mind. Base of 10, natural log uses a base of e. So for this first example, log of 19 equals 1.279. To rewrite that, 10 is the base, and so 10 gets raised to the answer, and it'll equal the number that we're taking the log of. So what that'll look like is 10 to the 1.279 power equals 19. And that's all. There's nothing to really calculate there. It's just sort of telling you, oh, FYI, that's sort of what it equals. I mean, it's not exact because the 1.279 is a rounded number. But if you rewrote it in exponent form or using exponents, you take the base of 10, raise it to the answer, and it'll equal the number that you're taking the log of. And that's all you have to do for that. Second example, same idea. A log of 4 equals 0.602. That would rewrite as 10 to the 0.602 power equals the number 4. That's all you have to do. Natural log of 26 is going to use a base of e. So instead of raising 10 to the power, we're going to raise e to the power of 3.258, and that'll come really close to the number 26. And again, if you can check these to make sure they work out correctly, to make sure you're on the right track, especially when you're doing your homework. But if you raise e to that rounded power, you get like 25.99. So again, those are rounded numbers, and you're just expressing log form into exponent form. The next example here uses natural log, so we'll use a base of e. Raised to the negative 0.437 power is going to give 0.646. Okay. To use some with numbers or letters, common logarithm is a base of 10, so we'll raise 10 to the t power, and that'll give us that p that we're trying to take the log of. And there's, again, nothing to plug in there. It's just so you're understanding how to go back and forth between log form and exponent form. Natural log of q equaling z. Natural log uses a base of e, so we'll raise e to the z power, and that should give us the q value that we're trying to take the natural log of. Last one here looks at log of 30 equals 1.477. That would rewrite common logarithm, so that's a base of 10, raised to the 1.477 power equals the number 30. Okay, so that's just rewriting logarithms, whether they're common or natural, into exponent form with the base of e or 10. Okay, these will go backwards. These examples are going to have you rewrite the exponent form using logarithms. So if you have a base of 10 that gets raised to the exponent, use a common logarithm, and if you have a base of e, 10 with an exponent, we'll use a common logarithm, and if we have e with an exponent, we'll use the natural logarithm. So 10 to the 8th power equals 100 million. That would be the log of 100 million. You can use parentheses if you need to, would equal 8. Because again, the log of a number is just what power on 10 would give you the 100 million. In this case, it's 8. The next one, e to the negative 4 equals 0.0183. It's an e, so we'll use natural log. So if I do the natural log of my answer, this 0.0183, it will give me negative 4. Because again, negative 4 is the power on e that gave me that number we were taking the natural log of. 10 to the v equals w. It's a base of 10, so we'll use a common logarithm. So the log of w equals v. Again, it's the power on 10 that would give us w, and I know that doesn't really have any application, it's just a formatting thing. So you take the log of whatever the answer is, and the answer is going to be the exponent on the base of 10. E to the a power equals b. E is your base. We'll use natural log. So we'll do the natural log of b equals a. Again, the a part is the exponent on the base of e, and the b that we took the natural log of, that's the answer that we're given in exponent form. Okay. Last one here on the bottom is another e. It'll use natural log. So if we rewrite this with a natural log, it'd be the natural log of 100 equals 0.12x. And again, we're not solving anything here. It's just putting it in to logarithm format versus the exponential format. So those are a few examples of those. Okay. A few questions that have you evaluate using natural logs. So I wanted to just run through just a few of those, even though we've sort of already done a couple of those previously. The log of 1,000, if you remember, is pretty much just what power of 10 would give you 1,000, and that power is going to be 3. So the log of 1,000 is just 3. These are sort of getting evaluated without the use of a calculator. The log of square root of 1,000, you can rewrite the square root. I was going to say if square root of 100, you could just make it 10, but square root of 1,000 is not exact. So if you rewrite this guy as the log of 1,000, you can rewrite a square root as a 1/2 power. And then because you're taking the log of a number and that number has a power, there is that property for logarithms that says the power can hop down front as a product. So this really becomes 1/2 times the log of 1,000. If you evaluate the log of 1,000, it's just the power of 10 that gives you 1,000, so that's 3. And if you take half of 3, you get 3 halves, which is 1.5, and either one of those are exact because there's no rounding to be done. Okay, so that's your answer for this one, 1.5. The log of 10 squared is what power of 10 would give you 10 squared. It's not a trick question. 10 squared is 100. The power of 10 that would give you that 100 is sort of sitting right there, and the answer is 2. Same for this next natural log example. Natural log of e to the 5th. Remember, natural log is a base of e. So you're really asking what power of e would give you that e to the 5th that's just sitting there, and you kind of already have it. That power is going to be just a 5. Okay. Plus, you could also think about natural log of e to the 5th. Because it's a natural log of e raised to a power, you could bring that power out front as a product and do 5 times natural log of e. And the natural log of e is just 1, because it's like what power of e would give you back e. And 5 times 1 is 5, and you get the same answer thinking about it a different way. Natural log of the square root of e. Square root could be rewritten as e to the 1/2. And again, if you have a power, the natural log of e, in a sense, they're going to cancel each other because they end up giving you the value of 1. But you can bring that 1/2 down. The natural log of e is just 1, and your answer is 1/2. So those are just a few evaluations of logarithms without the use of a calculator because they were some sort of form or exponent of 10 or e, so it makes them a little bit easier. And if they're not a power of 10 or a power directly on e, you are most welcome to use a calculator because there's not any other way to do those.